Well, class, the last thing we have discussed, I think exercise 2.4, question number 3 was the last question. Well, so we are continuing exactly the position where we left in the last Friday. Okay. Next, we are starting exercise 2.4, the question number 4. Exercise 2.4, question number 4. Well, now if two zeros of the polynomial is are 2 plus minus root over 3. So here exactly we have to find out the other zero. First, let me analyze the question. It is a polynomial of degree 4. So when it is a polynomial of degree 4, it will have maximum of 4 zeros. So out of 4 zeros, 2 zeros are given. Okay. So they are combining both the zeros and writing like this. So in fact, 1 zero is 2 plus root over 3, and another one is 2 minus root over 3. Another one is 2 minus root over 3. Okay, they are combining and writing 2 plus minus root over 3. Now we need to find out the remaining 2 zeros. We have done earlier one similar type of question, but in those questions, zeros were very simplified form, but here the zeros are a little bit complicated. Let us see how to solve this one. The procedure remains same, only the calculations you need to take care. See, you are given that 2 plus root 3 and 2 minus root 3 are the zeros of the given polynomial. Yes? 2 plus root 3 and 2 minus root 3. Suppose it is something like that, that x equals to 2 plus root 3 and another one x equals to 2 minus root 3. So when we transfer to the left hand side, x minus 2, look at this, x minus 2 and this plus will become minus, so minus root 3. This is also this x minus 2 minus root 3 is a factor of the polynomial. Again, for this one, x equals to 2 minus root 3. So whenever we transfer to the left side, x minus 2, this minus become plus. Okay, so x minus 2 plus root 3. So this is also a factor of the given polynomial. Look at this, we are getting two factors of the given polynomial from the zeros, right? Now you see, just think, suppose 2 is a factor of 8. So 12, 2 is a factor of 12, 3 is also a factor of 12. So if we multiply both the factors 2 and 3, then 6 is also a factor of 12. Hope I'm clear. So this is one factor, this is another factor. So their product will be also a factor. So we are writing that therefore this quantity product is a factor of the given polynomial. Now if we want to simplify this one, this simplification part, look at this. How to do this simplification? You assume this quantity as a, then x minus 2 will be also equals to a, and this is b. Suppose this is root 3 is equals to b, then root 3 is equals to b. Then what will happen? This is a minus b into a plus b. So it comes under
Sir?
the, yeah.
Sir, there's someone in the waiting room.
Okay. That's the reason I used to say that you please join on time, because once I concentrate on the slide explanation, then my mindset remain here. Anyway, so this is a, this is b, so a minus b into a plus b. So it is a square minus b square. So what will happen? It will be x minus 2 whole square, x minus 2 whole square minus root over 3 whole square. Yes, so using the third formula, then x minus 2 whole square will be x square, this is the x square, then 2 square, this is the 2 square, since it is minus, it will be minus 2ab, 2 to the 4 into x, this is 4x. Hope I'm clear. Minus root 3 whole square is equals to minus 3. Yes, so if we simplify this one, x square, no other term, so it is x square only, then This is minus 4x, no other like term. So as usual, minus 4x, and 4 and minus 3. 4 minus 3 is equals to plus 1. So what will happen? This is the simplified form of this one, and this is a factor of the given polynomial. I hope I am clear. One more time I am reminding you, this one and this one, it is the zeros given. From there we can say that this is one factor, this is another factor. So their product is also a factor, and that product after simplifying, it becomes x square minus 4x plus 1. So we can say that x square minus 4x plus 1 is a factor of the given polynomial disk. I hope it is clear. Now, suppose 3 is a factor of 12. If 3 is a factor of 12, 12 is completely divisible by 3. So when 12 is divided by 3, there is no remainder. In the same way, x square minus 4x plus 1 is a factor of this quantity. So when this polynomial is divided by x square minus 4x plus 1, then the remainder will be 0. Now the next steps, what we need to do, we need to divide this polynomial by x square minus 4x plus 1. Hope I'm clear. Now, before going to the next slide, I'm giving you one task. You do one thing. You divide this polynomial by x square minus 4x plus 1 by long division method. Do it in your copy. Okay, any rough copy, you do the calculation. Not in the main classwork copy, do it in the rough copy. So I'm giving you 2 minutes time. By the long division method, you divide this polynomial by x square minus 4x plus 1. Everybody.
Sir.
Yes.
Sir, do we need to do this exercise in the copy, in the school copy?
No.
Exercise
For the
2.4.
that whatever the PPT I'm sharing, the entire PPT will be there in your classwork copy, right? But now whatever the job, whatever the task I am giving you, that task, do it in the rough copy. I want to see whether you understood the long division method or not.
Yes, sir.
Yeah. So I'm giving you 2 minutes. You divide this polynomial x to the power 4 minus 6x cube minus 26x square plus 138x minus 35 by x square minus 4x plus 1. Long division method. Do this by long division method. Once you have done, just give me a thumbs up. Divide this polynomial by x square minus 4x plus 1 using long division method. I have explained those division many a times. It will be boring if I have to explain it again. Do it of your own, then I will share the answer. Then you can check it out yourself. And by that time, let me take the attendance. I will take the attendance now. There are total 25 participants till now.
Sir, can you kindly show exercise 2.2 again? Sir, I didn't understand that.
Okay, once the class gets over in the second half, okay, means again from 10 to 10:30 we have another class, na? So there I will share. Okay.
Thank you.
Okay. Sneha, very well, raise hand. Okay, Sneha, you have any doubt? Or, okay, she has completed, fine. Okay, Shivras Goswami, well done. Okay, two participants raise hand. One is nominally finished. Well, Vishanu finished. Who else? Ayush Ainam. Yes. Then Arhan finished. Chirmi, Isha. Then Ashi Agarwal, Sneha. Priyam, Siddharth, Udadita, Aditya Kesav. Well, 11 participants raise hand. 11 participants has finished. Okay, that's good. 12 participants have finished. 13 participants has finished. That's really encouraging. Said Borua, Jaina. Okay, 15 participants have finished. Well, that's a very good encouraging things. Yes. Now you just check your answer. Okay. Yes, this is the division. Check your answer. Is the question to x square minus twice x minus 35 you all are getting?
Yes, sir.
Yeah. That's very
Yes,
good.
sir.
Very
Yes, sir.
good. Yeah. So now, next. Now what exactly happened? This is the dividend, this is divisor, and this one is the question. Remainder is 0. So by division algorithms, this dividend can be written as divisor multiplied by quotient plus remainder. Since remainder is 0, I am not mentioning the remainder plus 0. Now look at this. This dividend we are getting by multiplying the divisor and the quotient. Now from where we got the divisor? Look at this. Again going back to the previous slide. The divisor we are getting, look at this. Divisor we are getting from the given zeros. This is the divisor, and this divisor we are getting from the This divisor we are getting from the zeros. So what will happen if you again try to solve this divisor? Okay, you will get the given zeros only, but the question says you have to find out the remaining two zeros. Already two zero is given, remaining two zero you need to calculate, and that's the reason I suggest you not to simplify again this part. Not to simplify again this part, because this part if you simplify you will get the given zero. Then better, so which part? The other part, that is the question whatever you are getting, that you need to simplify. Now it is a quadratic polynomial. This quadratic polynomial can be simplified by splitting the middle term. So if you split the middle term here, then you will get the two linear factor x minus 7 into x plus 5. I hope you know how to simplify it. Well, then what is the next steps? In the next step, you need to equate each linear polynomial with the numeral 0. So when you equate x minus 7 with numeral 0, you will get x equals to 7. And when you equate x plus 5 with the numeral 0, you will get x equals to minus 5. Hope I am clear. So what are the other two zeros? So other two zeros are, one is either 7 and minus 5. Is there any doubt in this question? If you have any doubt, just unmute yourself and raise the voice, okay, for this particular question. Please respond. If not, I will go to the next slide.
Sir.
Yes.
Sir, can you like explain how we got the first two zeros, like first two factors?
Okay.
How we got x square minus 4x plus 1.
Okay, fine. This one. We're moving back to the previous slide. You are given this x equals to this one, x equals to 1 0 we are talking about, 2 plus root 3. This is a 0. So when x equals to 2 plus root 3 is a 0 of the polynomial, we can say like this, that, just 1 minute, yeah, that x, this one you transfer minus 2 plus minus root over 3. It is a factor. It is a factor of the given polynomial. This is 0, and x minus 2 minus root 3 becomes a factor. In the same way, that remaining part you will get from the second one. X minus 2 plus root 3 is a factor. Okay. Then दो factor मिल गया, दोनों का product जो होगा वो भी एक factor होगा. Hope I am clear?
Okay, then we multiply both of them.
Exactly. Okay. So we are going to the next slide. Now exercise 2.5. This is a higher level of question, hot questions we can say, which was given in the optional exercise. So let us discuss this question. Well, please pay your attention. If the polynomial is x to the power 4 minus 6x cubed plus 16x square minus 25 plus 10 is divided by another polynomial, x square minus twice x plus k, the remainder comes out to be x plus a. ध्यान से देखो, in this question what happened, x is a variable in this polynomial. This is a polynomial, obviously x is a variable, it should be a constant term, but instead of that constant term they had mentioning it k. So definitely k is a constant, but we do not know what exactly is the numerical value of the k. Similarly, this is the remainder. Remainder is a polynomial, linear polynomial, but this one should be a constant term. But instead of that constant term, they mention it a. So we need to find out what is the numerical value of a. Hope I am understood what exactly is the question. Okay. So here, yeah. So here, what we will do, as normal way, we will do the things, but only The conceptual part is very simple, but a calculation, it requires a little thinking. Look at this. So normal way, we will divide this polynomial by long division method. Then we will see what is the remainder according to us. And that remainder will be equals to x plus a, because they said that the remainder is x plus a. Now let us see what will be the division. Well, so as usual, this is the dividend, this is the divisor. The very first step, I repeat, by how much x square need to be multiplied so that the result is x to the power 4. So from your observation, you can see that it has to be multiplied by x square. So once you decided that this term will be x square, okay, you multiply all the terms of divisor by x square. Okay, so x square multiplied by x square, x to the power 4, x square multiplied by minus 2x cube, x square multiplied by k will give us kx square. Then we need to subtract. While subtracting, the symbol will change. This plus will become minus, this minus will become plus, and this plus will become minus. Then x to the power 4 plus x to the power 4 minus x to the power 4 goes cancel. Minus 6x cube, this will become plus 2x cube. So result is minus 4x cube. Look at this. Yes, 16x square and kx square. So while subtracting, what we subtract? This variable, it remains same, only the coefficient we subtract. For example, here it is minus 6 and plus 2. Only the coefficient is subtracted and the variable remains same. So in the same way, here the variable is x square. So and when we subtract the coefficient, it will be 16 minus k. So 16 minus k will be the new coefficient of x square. Then this 25x, it is directly carried over, and this 10 also, it is directly carried over. I hope I'm clear. Next steps, we need to check by how much x square need to be multiplied so that the result is minus 4x cube. So we have decided that it should be minus 4x square. Okay, you have decided that it should be the second term of the question will be minus 4x. Then multiply all the terms of the dividend by minus 4x. So minus 4x into x square will give minus 4x cube. Minus 4x into minus 2x will be plus 8x square. This is, you see, plus 8x square. Then minus 4x into plus k, it will be minus 4kx. Look at this, minus 4kx. Again subtracting, this is minus, this will become plus, so both cancel. Okay, then 16 minus k is the coefficient of x square, and here the coefficient of x is 8. Now look at this, if we subtract the coefficient, it will be 16 minus k, 1 minute, okay, 16 minus k, and then this will be minus 8, so minus 8. So what will be the result? 8 minus k, am I right? So 8 minus k, look at this, 8 minus k is the coefficient. Hope I am clear. Okay, in the next steps, you see, then here it is minus 25x and here it is minus 4. So when we subtract, it will be 9 minus 25, okay, minus 25, and this will be minus will become plus. The coefficient of x is plus 4k. So it will be plus 4k. Now what happens, you see, if we take common minus, so it will be 25 minus 4k. Look at this, this is 25 minus 4k. Multiplied by x becomes minus. Then this 10 directly carried over. I hope I'm clear. Next step, by how much x square need to be multiplied, okay, so that the result becomes 8 minus k into x square. So you have decided that it has to be multiplied by 8 minus k. Then by 8 minus k, you need to multiply all the terms of the divisor. So 8 minus k into x square, 8 minus kx square, same thing. 8 minus k into twice x. Look at this. X is the variable, we'll keep it outside. And inside, minus 2 multiplied by these two quantities. So it will be minus 16 plus 2k. Look at this. It will be minus 16 plus 2k. Yeah, whenever we multiply the coefficient. So next steps, if we take common minus, okay, then what will happen? Inside it will be plus 16 and this will become minus 2k. I hope you understood. Look at this, minus we are taking common, so it will be 16 minus 2k multiplied by x. Then 8k multiplied, 8 minus k multiplied by k will be 8k minus k square. Yeah, I'm going very slow. Now this and this is the same thing, and this will become minus, so it will go cancel. Look at this, how much it will be. This quantity and this quantity we need to subtract. Answer therefore. So when we subtract, what will happen? This first term remains same, but the next term, what will happen? The symbol will change. So next time symbol will change means it will become plus, right? When it will become plus, 16 minus 2k and minus 25 minus 4k. So what will happen? It will be 16 minus 2k, 16 minus 2k, and here it will be minus 25 plus 4k. Minus 25 then plus 4k. Now simplify 16, okay, minus 2k plus 4k will be plus 2k. Look at this, this is plus 2k. And 16 minus 25 will be minus 9. Look at this, minus 9. Then this 10 is the constant term here, no variable involved, so this is also constant term. So this to be subtracted as usual, 10 will remain 10, this symbol will changes, it will become minus 8k, and this minus k square will become plus k square. I hope you understood. So this is what the exactly the remainder we are getting while the actual long division process was performed. Hope I'm clear. Now we'll go to the next slide. Just 1 minute, okay. Now look at this. So we are getting, this is the remainder. According to us, this much is the remainder. Fine. And they said that remainder is x plus a. So whatever is our remainder and whatever is their remainder, it must be same. Now, see, this is constant term into x, this is constant term. So it is something like that, something into x plus constant term and something into x plus constant term. So right hand side is a linear polynomial, left hand side is also a linear polynomial because this term is constant. Okay. So there is a method which we call the comparing the coefficient of like term. So what exactly is the comparing the coefficient of like term? Here it is x, here it is x. They are the like term. Coefficient of x is here 1 and the coefficient of x is minus 9 plus 2k. So what will happen? Minus 9 plus 2k will be equals to 1. That is called comparing the coefficient of like term. So minus 9 plus 2k equals to 1. So from here 2k equals to 10, we get k equals to 5. Hope I am clear. Then what is the next step? In the left hand side, this part is the constant term. And in the right hand side, this part is the constant term. There is no variable involved. So what will happen? This constant term and this constant term must be equal. So if we, yeah, next. If we compare the second part, so what will happen? Look, this is the constant term and constant term will be equals to a. Now the value of k is already known. So put the value of k here. Okay, so when we put k, the value of k is this much. So all k are replaced by 5 because we got k equals to 5. Right hand side is a. So after simplification, you got a is equals to minus 5. So this is the solution. You are required to find out the value of k and a. So we got k equals to 5 and a equals to minus 5. Hope I'm clear. Yeah, if you have any doubt, please let me know in this stage before going to the next slide. Unmute yourself and please let me know if you have any doubt. Yes, I'm allowing you to unmute yourself of your own one by one.
Sir?
Just yes,
Sir,
yes.
we don't have x in the step after step number 3, right?
Okay, we don't
Because
have
x on the left side and x on the right side got cancelled, right?
exactly. Actually,
After
what we are
substituting the value of k is equal to 5.
yes. Look at this here. What happened? The coefficient of x and here the coefficient of x. So we are equating the coefficient. Listen to the word. What exactly I'm telling? Equating the coefficient of like term. So something into x and something into x. They are the like term. Yes. Coefficient of x is here 1 and coefficient of x is here this much 9 minus 9 plus 2k. So we are equating. So on equating we are getting the value of k. And in the second steps, this is the term, it doesn't have any variable because initially it was told that k is any real number. And here also a is a real number. It is not variable, they say. We have to find out that value of the real number, okay? So this is constant term, this is constant term. So both the constant term must be equal because they said that this is the remainder and according to us, this is the remainder. Any other?
Okay.
Well, class,
Okay.
I think after 1 minute and 20 seconds, this meeting, the timing of this meeting will over. But don't go away. As soon as the meeting over, I'll start another meeting because the classes will continue. So, anyone else? If not, then we will go to the next slide. So, see this question, conceptual things is very simple concept, but the division process here, the division process, the subtraction, this taking common minus, here taking common minus, after subtraction, these are the spot where there is a chance that you will commit mistakes. So I'd like to request you all, okay, you do one thing, you just once we finish the classes, after that you practice these questions once more. Because I know at the very first attempt, you will commit mistakes in this type of terms.